All right, good. Today is day 17. Let's see. As your flight slowly drifts through the sky, the elves at the Mythical Information Bureau at the North Pole contact you. They're somehow debugging a malfunctioning experimental energy source aboard one of their super secret imaging satellites. The energy source is based on technologies that have Conway clues. In a pocket dimension, here attacking problems you create. Look at the pocket dimension. It's an infinite three-dimensional grid. Each intermittent three-dimensional coordinate, there's a single cube which is either active or inactive. You'll see the pocket dimension, almost all cubes are inactive. The only exception is a small flat region of cubes. Cubes in this region are in specified active or inactive state. The energy source proceeds to boot up by executing 6 cycles. Each cube only ever considers its neighbors. Any of the other 26 cubes or any of their coordinates differ by at most 1. For example, given the cube at x for this neighbors, during a cycle, all cubes simultaneously change their state according to the following rules. The cube is active, so it's like a game of life, but in 3 dimensions. Instead of following initial state, this is a small 2-dimensional slice in it. Particularly this, so in a few cycles, following configurations before any cycles equals 0 after 1 cycle, after 2 cycles, after 3 cycles is equals 1. So the full 6-cycle boot process completes. 112 cubes are left in the active state. Simulate 6 cycles. Okay, that seems straightforward enough. And so let's put this here. Typing import tuple named tuple class point named tuple and x int y int z int. Okay, and let us say that going back here, the grid is just going to be a set of points which are active. So let's say grid is going to be a set of points, which means I need set here. And what I want to do is I want to say step grid, which is a grid and is going to return a new grid. And neighbors, any of the 26. So first of all is what I want to do is I want to say def neighbors self goes to an iterator of points. Okay, so I need iterators. And for dx, dy, tz in import itertools. Itertools.product. I think I need I can never remember how this works, so let's do this. Import itertools. Itertools.product self product of the iterables. Okay, good. So we can say -1, 0, 1, -1, 0, 1, -1, 0, 1. If they're not all 0, so if dx not equal to 0 or dy not equal to 0 or dz not equal to 0, yield point self.x plus dx, self.y plus dy, self.z plus dz. Okay, so that'll give me the neighbors. And now what I want to do is the following, is I want to say candidates equals, and I'll just say P for point in grid for P in point dot neighbors. So basically I'm going to say and then we also need to say and then candidates equals set grid candidates dot extend P Okay, so I'm taking all the points that are in the grid and all the points that are neighbors for points in the grid. And maybe that's not necessary. But anyway, what I want to do is I want to say counts equals this for point in candidates n equals len of n equals sum p in grid for p in point dot neighbors. So that will tell me how many. And let me go back and look at what the problem said. There's neighbors. Exactly 2 or 3 of its neighbors are also active. The cube remains active. So let me start with this and say new candidates equals p for point in grid for p and point dot neighbors if p not in grid. Okay, so these are new candidates, and then I also have and let's say new grid equals set. Okay, so we'll do 2 things. For point in grid, how many neighbors? If a cube is active, exactly 2 or 3 of its neighbors are also active. If n is either 2 or 3, then new grid dot add points. Okay, and now for point in new candidates, again we have this, and now if it's exactly 3, new grid dot add points. Okay, so that should, and then return new grid. Okay, and finally I want to make grid raw, which is a string, and say lines equals raw dot split on n, and it doesn't really matter what we want to do, and so what we want to do is say return point of x, y, z for and x, y, 0, say, for y row in lines, in enumerate lines, for xc in enumerate row if x equals this, right? Okay, and so let's do that and say raw equals this and grid equals make grid raw, and let's just run this Advent 2020 day 17.py, and let's look at the grid, and that's not right. If C equals pound, not X. Let's try that again. And so now it's saying X equals 0, Y equals 2, X equals 1, Y equals 3, no, X equals 1, Y equals 0, and Y equals 2, and X equals 3, X equals 2, Y equals 1, Y, yeah, okay, so that looks right. And now what I want to do is after 6 cycles, so for blank in range 6, grid equals step, grid equals step grid, and then assert that len of grid equals 112. So let's run this and see if that's right. That is right. Okay, so let us do the same thing. Raw equals f.read, grid equals make grid raw. For blank in range 6, grid equals step grid, and print len grid. Okay, so let's try that and see what happens. 280. So let's try it. That's the right answer. Okay, good. For some reason, your simulated results don't match with the experimental energy source expected. Apparently, the pocket dimension actually has 4 spatial dimensions, not 3. It's a 4-dimensional grid. Each integer 4-dimensional coordinate, there's a single cube, which is either interactive. Each cube only shares neighbors. Any of the 80 other cubes are in the coordinates served by most one. For example, given the cube, its neighbors include that cube, and so on. The initial state of the pocket dimension still consists of a small flat. Furthermore, discern the number of active. Okay, so I am just going to make a complete another copy of this 4D version. I could refactor it, but so I'm going to call this 0.4, and it has X, Y, Z, and W. And this should be easy enough. Again, just do -101. Now we'll add a DW, and then or DW not equal 0, self.w plus DW, so that's good enough. And this should be 0.4. Expression of type iterator 0.4. Right, my type hint is wrong. And I'm just going to call this grid 4 is a set of 0.4. Step 4, this is awesome. And this might be the same, right? New candidates, I think this says the exact same rules, so I could use the same function, but I'm not going to. Grid 4, and again I can do this now. 0.4. Grid 4 equals make grid 4 of raw, and this is really messy, but you know, if I were if I cared, I would refactor it to do that, and assert that len of grid 4 equals and what they say, 848. let's run this and okay, so that worked. And I'm going to comment this out, and this might take a while. That's my worry. Grid 4 equals make grid 4 raw for I in range 6. Print I grid 4 equals step 4 grid 4, and then print len grid 4. Okay, so let us do that. 3, 4, 5, 6, 1696. So let's try it. Rank 174. So that's probably my best day yet. Although still not top 100. That's fine. I'm happy with it. So anyway, let us go and see if we can refactor this to make it much nicer. And so what I'm going to do is I'm going to say what I'm going to say is I'm going to say point equals tuple of, so a point is going to be a tuple of ints, okay? And what's, yeah, that's fine. And def neighbors, which is going to take a point, which is a point, and it's going to return an iterator of points, okay? And now what we're going to do is we're going to say dim equals len point, because we need that. And so let's say for deltas in itertools dot product of and let's say changes equals minus 101 for blank in range dim, okay, and for deltas equals itertools dot product for delta in if any d not equal 0 for d in deltas, yield tuple of x plus dx for x dx in zip of point and deltas. Okay. Expression of type iterator tuple any. Seriously? All right, that's fine. I'm not going to worry about the type hint. And grid is a set of points. Def step new candidate equals p for point in grid. Let me just flatten this out. For p in neighbors of points, if p is not in grid, and watch, I'm going to break my code and it's not going to work. That would make me very sad. New grid equals set. So again, I'm replacing this with neighbors points because it's no longer okay, and dim, which is an int, and turn xy plus and let's say pad equals tuple of 0 times dim minus 2, right? And return xy plus pad for, okay. So I'm just going to pad it out with zeros. And how many zeros do I need? I need dim minus 2. Okay, and so now I don't need the 4D version at all. And let's say grid 3 equals make grid raw comma 3. And grid 3 equals step of grid 3 and assert len grid 3 equals that. Grid 4 equals make grid raw comma 4 for blank in range 6. Grid 4 equals step grid 4 and that. And let me comment these out and see if my unit tests pass with this change. They do. All right. Why did that take a long time? It took a long time because grid 4 takes a long time. So again, let us do this and say grid 3 equals make grid raw comma 3 for blank in range 6. Grid 3 equals step of grid 3, and then grid 4 equals make grid raw comma 4 for in range 6 equals step in grid 4. So now we can run this and see if it works. Okay, 280 and 1696. I think those were what I had before. 280, 696. Good. So now the only thing is that let me see if I can make this work. I don't know why it needs that type in. Okay, good. So now we have a nice working solution. So what I've done is I've said now, a point is going to be a tuple of ints that can be any length. Okay, and now I'm going to, because of that, it's not a named tuple, so I can't add methods to it. So I'll just write a bare function to figure out neighbors and iterate over the neighbors. And so what I'm going to do is I'll say, I don't know what the dimension is, so I'll figure it out. So it's either 3-dimensional, it's 4-dimensional. And then these changes I need to look at are 0, -1, 0, or 1 in each dimension. And I know how many dimensions I have, so I make this list of changes. And then what I do is I use itertools product that says basically, the first delta is -1, 0, 1, the second delta is -1, 0, 1, and so on up to, if it's a 3-dimensional point, I get 3 of them, and so on. And so now I just iterate over the deltas. And what I do is I say, I don't want to catch the point again, right? So I need to, as long as one of the elements in the deltas is non-zero, then I create a new point which is adding the delta to each dimension, which I do with this zip, and then I want a tuple, so I just yield a tuple. And I say a grid is a set of points, and now the way I've set it up, a grid could have like 3-dimensional points and 4-dimensional points together, so ignore that. And then I define the step function from a grid to a grid, and again, Python's not going to have dependent types. If it had like dependent types, you could have like a grid for whatever. Anyway, we don't have that. And so what I do is I say, I know that cells come alive based on their neighbors, and so I'm going to look at all the points in the grid, but I also need to look at the neighbors of points in the grid that are not already points in the grid. So that's what I do is I say, for each point in the grid, I look at each of its neighbors, and if that neighbor is not already in the grid, then I collect it. And I use a set comprehension because things might appear more than once, and I don't want them more than once. And I say, I have a set of grid elements, and I want to return a new set, not modify my set. So I say, here's a new set, and I'll just stick the grid elements in it, and I say the rule said that if I have a grid, I count up which of its neighbors are active, and active just means it's in this grid. And if it has 2 or 3 active neighbors, then it's active again, and so I add it to my set of things that are active. Then I also have these new candidates, and I count their neighbors, and they go live only if there's exactly 3 neighbors. So I add them too, and I return the grid. Okay, so that's just this. That's exactly what the logic says. And then here's just parsing, and the only trick here is that I need to tell it what dimension do I want to parse into. Do I want to parse into 2 dimensions, 3 dimensions, 4 dimensions? And since they gave me something flat, I say I start with x, y, and I add padding of zeros for the remaining dimensions. So I told it, if I say I want 2-dimensional, the padding will be empty. If I say I want 10-dimensional, the padding will be 8, and it works out. And so that's it. Game of life in higher dimensions. We did it 3 and 4, and then we refactored. So cool, that works. And I will stop recording and push that up. So thanks for watching, and I will see you next time.